Hello everyone, welcome back to my channel. I am Bhagyashree, studying in BE third year at Sri Venkateswara College of Engineering, Bangalore. Today I am here with another new topic, Interpretable Machine Learning for Success Prediction in Computer Networks. Abstract. Higher education institutions are increasingly focused on identifying factors that influence student success or failure, aiming to implement early interventions to reduce low performance and dropout rates. Factors from various dimensions, personal, environmental, and institutional, play a role in student retention. In this study, we analyzed data from students enrolled in a computer network course to predict those at a risk of failing with the goal of providing timely support. For the first test, our model achieved 55% accuracy with a 63% success rate in identifying students most at risk of failing, which aligns with our privacy primary objective. For the second test, the model's accuracy improved significantly to 89%, correctly identifying at all risk students based on their interaction with the learning management system. This approach enables the earlier identification of students needing additional resources, allowing for timely interventions to prevent academic failure. Introduction. In recent decades, higher education has become a priority for governments worldwide, driven by strong correlation between advanced education and improved employment prospects. The growing number of higher education enrollments projected to increase by 56% by 2030 highlights the pressure on higher education institutes to maintain their prestige, often tied to student performance metrics. Low student performance and dropout rates remain critical concern, prompting the need for early interventions, educational data mining, leveraging the data mining and machine learning techniques offer valuable insights into student behavior and academic outcomes. Background. In higher education, understanding the factors that influence student success and failure has become a critical for institutions aiming to improve retention and reduce dropout rates. Machine learning, a branch of artificial intelligence that enables systems to learn from data patterns, has emerged as a powerful tool education data mining to predict students' performance. ML algorithms can analyze diverse data sets such as uh, soc- demographic information, previous grades and courses activities to identifying students at risk of failure or dropout. While ML techniques have been widely applied in various educational fields, despite availability of student studies on predicting student success in other subjects, no existing research has specifically addressed the application of ML in predicting student performance in computer network courses. This lack of academic work highlights the need for targeted efforts to develop interpretable machine learning models that can provide actionable insights for instructors, allowing them to intervene early and support students at risk of underperforming in these technical subjects. This study aims to fulfill this gap by exploring how ML techniques can be applied to predict and interrupt student success in computer network education. Methodology. The methodology for this study of interpretable machine learning for success prediction in computer networks involves analyzing data from first year students enrolled in 2 degree programs, informatics, engineering, and informatic technology. These students took a computer network course where performs was accessed through 2 written tests. The goal is to predict students' performance is this test, focusing on identifying at-risk students early to provide a timely interventions. Data from 4 sources were collected and integrated into 8 different data sets. survey data from voluntary student responses, interaction data from the learning management system, with tracks students' use of course resources, grade data from a related algorithm and programming or course, CN test grades, and for both tests. With the prediction models aimed at classifying students' performance levels in each test using these data set. For the first test, interaction data was used to predict GCN1, while surveying data and previous grades were added incrementally to access their impact. For the second test, GCN2, the models also included interaction data between tests and performance in the first test. Decision trees were trained for each dataset using Python scikit-learn library and model evaluation. Literature review. Interpretable machine learning has emerged as a valuable tool in education, enabling educators to predict student success and identify those at risk of failing. By analyzing data from various sources such as student surveys, interaction with learning platforms, and previous academic performance, models can provide insights into student behavior and performance patterns. Although ML has been widely applied to general education and programming courses, its use in technical subjects like computer network remained unlimited. This study seeks to bridge that gap by applying interpretable ML techniques to predict student performance in a computer network course, allowing early interventions and improving overall student success. The result demonstrates the using decision trees to predict student performance in computer network courses yields varying levels of accuracy depending on the dataset and factors considered. For predicting the first test grade GCN1, in incorporating only student interaction data achieved an accuracy of 50%, which increased at 54% when previous grades were added. However, including survey data increased the accuracy suggested that it has limited value in explaining performance at later stages. For the second test grade GCN2, interaction data and previous grades were more predictive, with the highest accuracy reaching 89% when AP grades were included. The decision tree effectively identified students at risk of failing with a 63% accuracy for the first test and perfect 100% for the second test. This highlights the significance of prior academic performance and LMS interaction as a key predictor of success. Conclusion. In conclusion, the study of highlights the transformative potential of digital tools and machine learning in enhancing student performance within higher education, especially in computer network course by utilizing various datasets including LMS predictors of academic success, pinpointed student requiring including LMS interaction and student grades, we effectively identified key predictors of academic success and pinpointed student requiring additional support. Despite the promising outcomes, further research with a large sample size is essential to validate these curricular units and diverse course aiming to develop a comprehensive framework that can guide a educational. Future work will focus on extending these analyses to other curricular units and diverse courses, aiming to develop a comprehensive framework that can guide educational interventions and improve student retention rates across the institution. Thank you for watching. Please like, share, and subscribe.